So let's see, what did I discuss in the last class? I think we discussed only the push-pull inverter in the last class, isn't it?
Yes, sir.
Sir.
And have you understood the operation of push-pull inverter?
Yes, sir.
Sir, I had a doubt in the push-pull inverter.
Okay, what is your doubt? Let me open that.
Sir, in the last class, in state B, the equation for the output voltage was L minus L didt plus VD. Also, sir, we wrote that L didt is greater than VD. So, sir, VO should be negative. But, sir, in the curve, we have drawn that VO in state B is positive.
Just a minute. State B.
Yes, sir.
Now, what is your doubt? BO, you are saying that BO is negative.
So, negative.
Okay. Now you are saying here is negative because LDIT is more than VD.
Yes, sir.
Okay, so have you checked the polarities? What is the problem in that equation? Did anybody check the polarities? And what was the curve over there? Okay, so this you are saying this portion, that means the B.
Yes, sir.
Your question is why I have drawn this as in the positive half.
Yes, sir.
Okay. Now we have to check the polarity whether we have drawn it correctly or not. So you just also try to see the polarities. Actually, what will happen in this circuit? Actually, which color we have used for that? Yellow, no? Okay. Now, when in the second state, state B, the inductor polarity will be this one, the yellow one. Is it? কি তাই তো? বোঝা যাচ্ছে না কেন? এটা তো আমি আগের দিন তোমাদের বলে দিয়েছিলাম। দেখো সার্কিটের এটা দেখলেই বুঝতে পারবে, পাথটা দেখলেই বুঝতে পারবে। I also mentioned which color I have used for what. Actually, I have used the black lines for the state A, the yellow lines for the state B, the dark blue lines for the state C, and the sky blue line for the state D. So I mentioned this clearly in the last class. Now you see, when in the state B, if you only write the equation for the secondary, okay, now what will be the equation? Let me know. Suppose we have only the equation for the secondary. And suppose you have an inductor like this. Suppose you have an inductor here, okay, and that has the polarity like this. Okay, suppose that is a voltage source. And what is the voltage of that? L di dt. And you have a load over here. Just a minute. So you have a load over here. What you can write from this? What is the KVL for this particular loop?
L di dt minus V out equal to 0.
So that means V out equals to L di dt. Okay, so that means I think we have used the opposite polarity here, isn't it? So this should be positive, then this must be negative. Okay, and also we have to see the same thing for state D. Is it okay for state D? That is the sky blue color thing. There must be V0 equals to minus L di dt. Okay, so I think that we have written correctly here. Okay, so that is the change you have to incorporate in this equation. Is it okay now?
Okay, sir.
Okay. Any more question on push-pull inverter?
So,
Yes.
if in the second, in the state B, it was LEFF DRDT minus VD, then in the fourth case, it must be minus LEFF DRDT plus VD.
Why?
I mean,
That why it is plus VD or minus VD, that I discussed in the last class. Now this is in this way. Here we discussed that thing. That we discussed. Why we are getting this minus VD, that we discussed. Only that inductor, the secondary portion in the state B, we haven't observed the sign for LDITT. Okay. In both the cases, state B and D, it will be in the regeneration mode. So therefore, it will be minus VD only. Isn't it? Am I right?
yes, sir.
Did I mention that? So both in A, the state B and D, it will be in the regeneration mode. So that means in opposite direction to the VD, the current will flow. So therefore, the voltage we got negative. So that is okay. But the problem was in the sign of the LDIDT. As per the given sign, our KVL was incorrect. So this change you have to incorporate in your note. Okay, so only the state B equation. Okay, so any more question? So we have already.
Sir, in the curve that you have drawn, for state A and state C, they are constant, minus VD and plus VD. But
Yes.
for state B and D, how did you draw the curve for V0?
Okay, so that is basically this the solution of this particular equation. So that is the differential equation. Okay, and there will be some sort of resistance as well. So that we have not shown here. Now, if we have an okay, so LR circuit, RL circuit, then you have this type of response. So we are not going into the details of the circuit analysis, but if the load will have resistive as well as inductive component, and your transformer is already has some inductive component, So there are two inductive component in the load as well as in the due to the transformer, and your load has some resistive component, your transformer also has some resistive component. Okay, so that means your circuit is basically an RL circuit. So if you are going for the solving for the RL circuit and in the differential equation, if you solve, then this type of exponentially decaying curve you will get. Got my point? For an example, I am just giving you an example. You can do this exercise. Suppose you have an RL circuit like this. Okay, and the current is the output in this case. Now, if we want to draw the current response with the versus time, so that is called the time response or current response, then what kind of current response we should get in case of the switch is closed for a very small interval of time. Okay, that means we have just closed and then opening. For very small time, we have the switch was in the closed condition. So that means almost an impulse, voltage impulse was there across this RL element. So what kind of current response you should get? Can you tell me? You just try to draw in your exercise book and show me. So this kind of knowledge you should already have from your circuit theory or any other Laplace transformation, etc. This type of knowledge or control system knowledge. Okay, so are you trying?
Sorry, exponentially decaying.
Okay.
Sir, আপনি impulse response জানতে চাইছেন?
Correct. I want the impulse response because I have already told you that switch will be closed for very small interval of time. That time for which the switch was closed is tends to 0. Now, one thing when you are solving this type of equation, this type of response, without going to the for the dynamic equations like differential equations or the Laplace transformation approach, now you have to see in the circuit that what is the initial current, and that means what is the initial value for this current. What is the initial value? Are you getting what I am asking you?
0.
So it was 0. And what is the final value?
0.
Final value will be 0.
Final value V by R.
বলো কি হবে?
0.
Why is 0?
স্যার এটা তো ইম্পালস রেসপন্স, মানে তারপরে তো ওপেন করে দেওয়া হয়েছে।
Correct. So have you understood this? So that means in this circuit you have initial value 0 and final value 0. So in the meantime something has happened. Now when the switch was closed for a very small time, what happens in the circuit? So what type of response you should get? Have you solved this type of circuit before? So very simple circuit. Yes. You must have solved in your circuit theory classes. Just a first order system What kind of response you should get? Are you trying
Sir,
to draw?
exponential decaying.
But from where it will start? It should start at this point because it has a zero value at the beginning, at the initial condition is 0. And you also, it should have the final value 0. Your initial value is 0. Your final value is 0. Okay, so that means you should get this type of response. Are you getting?
Sir,
Yes.
sir, I0 minus will be 0, but if we derive the expression for IT, then I0 plus will be 1 by
Yes,
n.
sir. V
So-
by L.
Yes, absolutely, V by n.
Okay,
So
but it should start with the 0 only, na? It will start with the 0
Sir,
only.
I0 minus is equal to 0, but I0 plus will it be 0?
No, 0 plus will not, is not 0, but it will take some time to be get that value.
Sir, is it a practical curve? And but what we are getting, that is actually theoretical. So that means there is some difference between theoretical derivation and practical curve
Okay,
of this type of
so
circuit.
okay, for any impulse response for this first order system, have you tried? Okay, anyway, so you just try to solve this circuit. Yes.
So here you are keeping the switch on for a brief moment, right?
For?
I am asking that here you are keeping the switch on for a brief moment, and then you are
Yes.
turning the switch off.
Yes.
Yes.
Okay. So that means you are saying somebody is saying it should start from here, and there should be some sort of discontinuity. And this you are referring as a theoretical curve. Am I right?
Yes, sir.
Okay. So you just try. So you are saying that this will be your I0 plus and it should decay from exponentially. Are you saying like this?
Yes, sir.
Okay, you just try. And what is this point I0 plus?
V by L.
Is it V by L
Yes, sir.
or V by R?
V by L.
Why V by L? Initially, what happens?
So there must be transient.
There
You
must be
haven't drawn
transient.
it in the stated diagram.
No. I'm asking what from which value you are saying that there will be some finite I0 plus value. Now, what is the I0 plus value? Is it V by L or V by R? That you check.
Sir, it has come V by L.
V by L. Why?
Sir, I0 plus value must also be 0. I mean, current cannot change its value instantaneously.
Correct. Anyway, so
We
you
are
just
turning
try.
the switch on at time t equal to 0. So at the next moment also the current must be 0, right?
Okay, so if it is a exactly impulse, absolutely you have correctly point out. If it is an exactly impulse, then it may be having this type of response. But in case of practical cases, you get this type of response, and also if there is some capacitive effect, okay, so then also you will get this type of response because the capacitive effect will come from your device itself. Okay, so this curve is a practical one. Is it okay? So you can also try for an LCR circuit. And for that, if you plot the response, then you must get this type of response where it will start from 0, it will reach some value, and then it will decay to 0. Okay, and that capacitive effect will come from the device itself. When I will discuss the device, then you will understand what kind of capacitive effect we may get from the device. Okay, so anyway, but if this value you should check it is V by R or V by L, because initially the inductor is very
Sir, it is
high.
V by L. Sir.
V by L only, no?
Yes, sir.
Okay.
V by L.
Anyway, so I think you have understood this point. Why it is there is a dark in the current, then it is decayed to 0, and we have to wait for the current almost becomes 0, because at any point it will not reach the exactly 0 value because the exponential curve. But we have to wait some time for switching the next switch. Okay. So have you understood? Okay, question ta korle.
Yes, sir.
Have you understood why we are getting this type of response? This is basically
Yes,
either you can take
the
the RL circuit for that, or you can take RLC circuit for that. Now see, we cannot explain from this third because we haven't drawn any capacitance in the circuit. But there, in case of practical case, there will be some sort of capacitance in the device itself. Okay, so though the theoretically it is like this, the practical one will be like that. Okay, and sometimes if you can also do this in your if you know the simulation, PSpice simulation, or sometimes also it shows this type of response. That also you have understood, because as it is a this RLC circuit or LCR circuit, then it depends on the values of the capacitance, inductance, and resistance, that how it will damp down, how it will decay. Are you getting? Okay, so
Sir, your sound is sometimes weak and sometimes strong.
I don't know. That is due to the network issue. Now I am saying that though I have drawn the practical curve like this, so another one you can get like this, and that depends on the value, exact value of the of your circuit, exact value of L, C, and R. So this, whether it will give this type of response 1 or response 2, that depends on the value of L, R, and spurious capacitance C. So this C I have not drawn yet in the circuit, but there will be some spurious capacitance due to the device itself. Okay, so any semiconductor device, there will be some sort of spurious capacitance. Okay, so due to that, you may get either a response 1 or response 2. But the response, the ideal response, you will not get in at any case. That I have drawn by the dotted line. That you will not get. Now, am I audible clearly? Have you understood
Yes,
this?
sir.
Have you understood this?
Yes, sir.
Okay. The next thing which I was discussing is the half bridge inverter. So here also we can get the 4 states that we have obtained for the push-pull inverter. But in case of a purely resistive load, only we'll get 2 states. Okay. Let us see what we'll get for the resistive load first, then we'll discuss for the inductive load. So in case of resistive load, purely resistive load, if the switch S1 is closed and S2 is open, S1 is closed, S2 is open. Now what will be the direction of the current if this is closed? So the current will flow like this. So this is the direction of the current. See the direction of the current through the load. Okay. Now you just tell me the voltage expression for this.
Plus VD by 2.
What is V0? It is plus VD by 2, isn't it? Do you agree?
Yes.
Okay. In the next state, S1 is open and S2 is closed. So that means this will be closed, and how the current will flow if that is closed? Let us draw the complete path, then we'll discuss this. Now it can not go upward, it should go downward, and this is how it will complete the path. Now see the direction of the current through the load. It has reversed, isn't it? So therefore your voltage equation V0 will be what? It will be minus VD by
2.
So have you understood this concept? So these are the two states I have just discussed. Here I have assumed it is purely resistive load. So therefore the D1 and D2 will not function at all. So these are the two directions of the current at two states. And we are getting a typical inverted current waveform, that is plus VD by 2 and minus VD by 2, like this. So this is your V0T, and we are getting plus VD by 2 and minus VD by 2. Is it okay? Any questions do you have? You just observe the current direction properly. Okay, the thing is here in the state A, one capacitor will act, that is the C1. In the state C, the other capacitor will work, that is the capacitor 2, C2. But through the load, the current direction is getting reversed. So therefore, as per the KVL equation, we have to write for state A, V0 equals to plus VD by 2. And for state C, V0 equals to minus VD by 2. Now, if we have inductive load, then we'll get other two states. Similar to the previous case, that is in case of push-pull inverter. Okay. Have you understood what I am saying? Because in case of resistive load, your current can flow exactly as your output voltage waveform. Am I right? Have you understood what I am saying? In case of purely resistive load, your current will follow the nature of the output waveform, voltage waveform exactly. What does it mean?
Load is resistive.
Okay, load is resistive. That means your current will follow exactly the output voltage waveform. Why? If I draw the current, let us draw the current. So how the current will look like? Can anybody draw the current in the same graph of the V0? If I want to draw the I0?
Yes, sir. VD by 2R minus VD by 2R.
And is there will be any transient?
No, sir.
Why? Why not?
Because resistance is in resistor is not a current. That means energy storing element, or that means it doesn't show any transient.
Okay. আর কেউ বলবে কিছু? অন্য একটু ভাবে এক্সপ্লেন করা যায়? হ্যাঁ বলো।
সার্কিটটা মানে এখান থেকে মানে আপনি যেটা ডায়াগ্রাম দেখান সেটা তো সেটা হচ্ছে যে সার্কিটটা ডিসচার্জিং অফ আ ক্যাপাসিটর।
কি বলছো বলো, আমি বুঝতে পারলাম না। আমি বুঝতে পারলাম না কথা কিছু।
সার্কিটটা দেখে মনে হচ্ছে
তোমার
ডিসচার্জিং অফ আ ক্যাপাসিটর।
হ্যাঁ, না ক্যাপাসিটর আমি আইডিয়াল ধরে নিচ্ছি। Capacitors are ideal here. So capacitors are sufficiently large that can act as a ideal voltage source. Now I am asking you that, okay, so capacitor is not the issue here because capacitor is sufficiently large and you can take it as an ideal voltage source. Now my question is, I am just made a statement that in case of purely resistive load, the current, output current will follow the output voltage exactly. Why I have made this statement? So one explanation I have got from Swarnadeep that there is no other energy storing element like capacitor or inductor. So that is right, because there is no inductive component in the load as well as there is no other capacitances. If I take ideal cases. If I take ideal cases, there will be no other capacitance or inductance. So any more explanation you have why it is following exactly the same like the voltage? From mathematical point of view,
sir, resistance
So
allows
V is equal to I.
বলো যা শুনতে পাচ্ছি না আর কি আমার এখানে নেটওয়ার্ক সমস্যা হচ্ছে নাকি
না স্যার আজ কোনো প্রবলেম হচ্ছে না এরকম
ব্যাস তাহলে স্বস্তিক বলে দিয়েছি যেখানে তাহলে তো হচ্ছে না নেটওয়ার্ক প্রবলেম
স্যার মাঝে মাঝে সাউন্ডটা খুব মানে কম হয়ে যাচ্ছে
হ্যাঁ তাহলে হয়তো আমার ডিভাইসেরও সমস্যা হতে পারে জানি না না এটা কি অন্যভাবে কিছু বলা যায় একটা তো বুঝলাম যে এনার্জি স্টোরিং
আপনার মাইক্রোফোনটা দূরে চলে গেলে তখন আসতে হয়ে যায়
আমি দূরে সরে গেলে আচ্ছা আমি খুব কাছ থেকে বলছি এখন এটা তো সবসময় ক্লাস নেওয়ার সময় সবসময় আমরা তো ডায়াসের ওপর হেঁটে চলে ক্লাস নিয়ে অভ্যস্ত এখানে বেশিক্ষণ অ্যাটেস্ট্রিজ বসে থাকলে ঘাড়ে ব্যথা হয় অলরেডি ব্যথা শুরু হয়ে গেছে যাই হোক চেষ্টা করছি যতটা সম্ভব মাইকের কাছ থেকে বলার আচ্ছা কেউ অলরেডি এতে স্বর্ণদীপ একটা বলেছে আর কি কেউ অন্য রকম ভাবে এক্সপ্লেন করতে চাও ব্যাপারটাকে দিস ইজ ভেরি ইম্পর্টেন্ট থিং ইউ শুড আন্ডারস্ট্যান্ড দিস
Sir, resistance allows abrupt change of voltage across it.
Correct. Why? Okay. Anybody else?
Because resistance is only energy dissipating device. It doesn't store energy, and
so that theoretically we all understood, but mathematically, can we show that? কেউ একটা বলছিলে মেয়েদের মধ্যে কেউ একটা বলছিলে সে বলতে বলতে মাইকি সমস্যার জন্য বন্ধ হয়ে গেছে
So I was saying that V is equal to IR. So if the load is resistive, then the current is a scaled version of the voltage.
Okay, that is a good explanation. কিন্তু আমি একটু অন্যরকম চাইছিলাম এক্সপ্লেনেশনটা যাই হোক সেটাও ভালো যেটা বলেছে সেটাও খারাপ কিছু না basically here in this expression it is what kind of equation it is linear obviously linear or
algebraic
it's an algebraic equation isn't it it's an algebraic equation
yes sir.
Now if I have inductive or capacitive part then what kind of equation it will be differential equation okay so when we are talking about the differential equation it becomes a dynamic equation and there are different states okay now the order of the differential equation give you the number of states now here we have state one state now in case of algebraic equation it's not a dynamic equation it's just a static equation got my point so when we'll solve the differential equation
yes,
so you must get state change there will be a difference between two states so discrete difference between two states okay so that is the difference in case of differential equation always you will get this type of thing but not for algebraic equation algebraic equation your response will exactly follow the input so therefore we'll get this type of thing so anyway so we are discussing now if the resistive load is replaced by an inductive load then what will happen so then we'll get the similar thing because if there is an inductance it will store some energy in the states A and C. The stored energy in state A should have some interval, some time to dissipate properly in some other state, and we can provide the state B for that. Not only that, we also have to provide some path for that. Now you just tell me that if the load is inductive, that means if the state A is carrying the current from top to down in the load in this particular circuit, then in the state B, which path will be followed to dissipate the inductor energy? That's my point. Now here,
it would try to keep it same direction.
Bolo, it will try to
that would try keep the same direction.
correct. Correct.
Yes, sir. So the direction is same.
দাঁড়াও, এখানে সব হ্যাং করে যাচ্ছে, কেন বুঝতে পারছি না। আচ্ছা, তো কোন ডায়োডটা কাজ করবে সেটা আমি জিজ্ঞেস করছি।
D2.
Okay. And what will be the path? Suppose you have inductor here, and this was the direction of it is the polarity in case of state A. Now we must draw it by YOLO in state B. And what is the direction of the current through load? It will remain the same. That means here the YOLO also will be downward direction as per the black one, because black one will be reflected to the YOLO one in the state B. Okay. বুঝতে পেরেছো? তাহলে এইটা তো আর এখান দিয়ে যেতে পারছে না, তো এইখান দিয়ে যাবে এটা, কি তাই তো? কোন ক্যাপাসিটরটা কাজ করবে?
C2.
C1 আর C2? No option of C1 because you have already open circuited that. Okay. So this is the direction of current. You see the direction of current in the source VD by 2. You see the direction. So that means it is in the opposite direction. Correct. Now what expression can we write here for the output voltage? Okay, first you try to write the KVL, then you tell me. As per the yellow line, you try to write a KVL equation. Then you just let me know what will be the KVL. All you try. যে ইয়েলো লাইনটা ড্র করেছি সেই এটাতে আমার কেভিএল ইকুয়েশনটা কি হবে? Considering the ideality of the switches. You can start at any point. Suppose you start from here. এখান থেকে শুরু করো। বলো, what will be the KVL equation?
Minus VD by 2.
We saying, আচ্ছা অন্য কেউ বলো, আরেকজন বলো।
minus VD by 2.
Why minus VD by 2?
So minus VD by T plus of minus DO equals to 0.
না না আগে বলো minus VD by 2 কেন? Because we are moving from
high potential to low potential.
So we actually there is a voltage drop. We are moving from plus to minus. In the source, we are moving from plus to minus. So therefore, it is minus VD by 2. Okay, so then next comes the inductor. What will be the inductor polarity?
minus plus.
দাঁড়াও আরেকজন কাউকে জিজ্ঞেস করি। রোল নাম্বার 13। Roll number 13. Roll number 13 নিশ্চয়ই ঘুমিয়ে পড়েছে ক্লাস করতে করতে। নেক্সট রোল নাম্বার 14 হিমাদ্রি দাস। একটু মাঝে মধ্যে চেক করা উচিত যে আদৌ কেউ ক্লাস করছে কিনা। আমার তো খুব ডাউট হয় যে ওপাশ থেকে কেউ ক্লাস আছে কিনা। যেমন এই যে রোল নাম্বার 13 and 14 is not there in the class physically, only their devices are on. Okay, roll number 34 Pushpal. Roll number 34.
Yes sir.
Can you tell me the next term in this expression in this KVL?
Sir,
it's just a KVL. You should respond to this. If you don't write, you can't write a KVL equation. You should not study in class third year class.
Sir, am I audible?
Yes.
Sir, I think it will be minus LDI by dt.
Why?
It looks like. Yes, I think it's so because it's minus VD by 2 and it is. Yeah, I think it will be minus LDI by dt.
I think okay. So let me ask somebody else. Roll number 31 Doipayan Guho.
Hello.
Yes.
Hello, sir.
Yes.
So I think it will be minus VD by 2 and then minus LDI by dt because of the inductor of the load.
No, you just follow the KVL equation. Inductor is not the issue. Across the inductors, always will get LDI by dt. Not minus. LDI by dt is the voltage drop across the inductor.
Yeah.
Now, as per the given sign, we are following the YOLO signs and YOLO paths because we are discussing the state B. As per the YOLO signs and YOLO current directions, what will be the next term, voltage term?
So for the yellow one, it will be plus. For the I thought for the blue one.
Why you have? I have not asked for the blue one because blue one is a different. That is a state C.
Yes, sir.
You are not following the class. Now, if we consider the YOLO line and YOLO sign, then what will be the voltage term? Next voltage term. You just clearly
So
tell
then
me.
plus. It will be plus.
Why?
It will be, sir, because the capacity across that capacitor, it is already
Not that is
the polarity changes from the
no. That is not the reason. That is not the reason. Can anybody tell me other than Swarnadip and Swastik?
Sir?
Yes, Anando, bolo.
Sir, L এর across polarityটা reverse হয়ে যাচ্ছে কারণ L টা মানে অপোজ করবে।
সেটা তো আমি দেখিয়েছি। L এর across এ তো সেই সাইনটা ধরেই তো তোমাকে এক্সপ্রেশনটা করতে হবে।
হ্যাঁ, তাই এটা প্লাস LDI বাই dt হবে।
হ্যাঁ, কেন প্লাসটা কেন হচ্ছে?
কারেন্ট ডাইরেকশনটা মাইনাস থেকে প্লাসের দিকে যাচ্ছে তাই।
Correct. So this is a simple answer. Here we are gaining the voltage because we are moving from negative to positive. As per the yellow lines, as per the yellow signs, yellow current direction and yellow polarity of the inductor voltage, we are moving from negative to positive. So therefore it is plus LDI by dt. এই সিম্পল কনসেপ্টটা যদি তোমাদের না থাকে তাহলে তোমাদের থার্ড ইয়ারে পড়ার যোগ্যই নাই তোমরা। সেম একটা সিম্পল কেভিএল ইকুয়েশন কেউ লিখতে পারো না, তোমরা পাওয়ার ইলেকট্রনিক্স পড়ছো। অর্ধেক জন ডিভাইসটাকে অন করে দিয়ে ঘুরতে চলে গেছে। হোয়াট ইজ দিস? Who is this roll number 12 and who is the roll number 13? I have asked this. Who is roll number 13 and 14?
Sir, yes sir.
কোথায় ছিলে তুমি?
Sir, roll number 14 বললেন।
রোল নাম্বার 13 আমি কল করেছি।
Yes sir.
তুমি কোথায় ছিলে?
স্যার আমি তো রোল নাম্বার 14 শুনলাম স্যার।
Roll number 13 I called and then I called roll number 14.
স্যার আমি ঠিক শুনতে পাইনি স্যার। আমি 14 ভাবলাম তাই আর কিছু বলিনি।
Okay, so what is the next term? Can anybody tell me? What will be the next term in the KVL equation?
Sir, minus VR.
Minus? Okay, so minus V0. Okay, VR we are considering as output voltage only. So minus V0 equals to 0. So this is the KVL equation because again we are moving from plus to minus. You should revise your knowledge for the basic KVL that you have learned in the basic electrical engineering classes. You all should revise. If you don't know how to write the KVL KCL equation, then you should revise. Otherwise you just leave the electrical engineering. সবার জন্য সবকিছু নয়। Same expression we have also obtained in earlier cases. So V naught equals to L di dt minus Vd by 2. The same expression we also obtained for the push-pull inverter, isn't it? Am I right?
Yes, sir.
No, sir, it was VD.
Only VD was there.
Okay, but here we have already taken the 2 Vd by 2 Vd by 2, no? So that is that change already we have observed. Now the signs are similar, na? Here what we obtain in case of push-pull inverter, and there the inductance also different. So their inductance we was getting for the cumulative effect of the combined effect of the inductor due to the transformer as well as due to the load. Now here the inductor we are only getting from the load. Here we don't have any contribution of the transformer inductance because here we don't have any transformer. Okay, so that is.
Sir,
that
here I have a question, sir.
Yes.
Sir, you have considered the RL load, but still why we are only considering the output voltage across the resistor instead of the complete RL load?
Output of the Load across the load only you will get the V naught, na?
Sir, please repeat.
Across the load only you will get the V naught, V0. Now load has its inherent inductance. Got my point? Load has its inherent inductance, and that will act as a source in this particular interval. So that we have separated out.
Okay.
বুঝতে পেরেছো? লোডের মধ্যে ইন্ডাকটেন্সটা আছে, কিন্তু ইন্ডাকটেন্সটা যেহেতু এখানে সোর্স হিসেবে কাজ করছে, সেই জন্য আমাকে ওটা আলাদা করে দেখাতে হচ্ছে।
ওকে স্যার।
বুঝতে পেরেছো? মানে প্র্যাকটিক্যালি যদি আমরা মেজার করি, সেখানে তো ইন্ডাকটেন্সটা লোডের বাইরে কিছু নয়। তুমি তো মানে ওই লোডের অ্যাক্রসে তো ভোল্টেজ মেজার করবে।
ইয়েস স্যার।
তাই না?
ইয়েস স্যার।
So we cannot get VL and VR separately. Okay. Now come to the state D. Now what is the direction of state D? Obviously it will pass through the diode D1. Okay. And which capacitor will act in this case?
D1.
C1 only. C1 capacitor will act in this case, and the current direction will be as per the dark blue, because that current it has to maintain. মানে এর আগে স্টেটে এই ডার্ক ব্লু লাইনটা ছিল, তো ইন্ডাক্টর সেই লাইনটাকে ফলো করার চেষ্টা করবে। Okay, so this is the current path. Have you understood? So okay, so
Yes.
let me write the expression, the signs, the polarities. Here the change in polarity. So this change you have to observe properly. So you see the change. Here also this change you have to observe properly. Okay, so as per the sky blue line, what will be the equation? What will be the KVL equation? Somebody should tell me the KVL equation rightly. Orko Prabhu Nandi.
Yes, sir.
So as per the sky blue line, can you tell me the KVL equation?
Yeah, yes, sir. First term will be minus VD by 2.
Okay, so I am starting from here, correct? It is minus VD by 2,
Yes, then we will get plus V naught, the
plus V
load
naught.
plus V naught.
Hmm.
Then we will get plus LDI by dt.
So you are saying minus VD by 2 plus V naught plus L di by dt. Have you all checked this? Whatever he is saying, is it correct?
Yes.
Look at the circuit once again. সার্কিটটা দেখে বলো, এখানে সার্কিটটা হ্যাং করে গেছে। বলো সার্কিটটা দেখে সবাই বলো, আশা করি সবার খাতায় ড্র করা আছে। কি হবে কেভিএলটা বলো। You all should check the circuit, the KVL equation for as per the sky blue lines.
Yes, sir.
And the polarity.
Correct.
Okay. So that was the correct KVL equation dimension. So that means V naught equals to L di dt minus L di dt plus Vd by 2. Is it so? Okay. So this is the output equation for state D. So that means in case of RL load, what type of response we should get, what type of output voltage we should get. So this is the first one. Okay. Then so that means this is your Vd by 2. This is your minus Vd by 2. And this is your state A, B, C, and this is D. And this is again A, and this is B. So here actually your the S1 is acting. Here your S2 is closed. Here the D2 is in operating condition, and here it is D1, and here again it is S1. Is it okay? Is the voltage output waveform is okay for RL load?
Yes, sir.
Okay. So this is all about the half bridge inverter. Next, we should go for the full bridge inverter. Okay, so let me first. Scroll up. বলো কোথায় যাব? সার্কিটটায়?
Just hold it in the graph and just 1 second. Okay, sir. Done.
Okay. So if you want, I can take a special class on this inverter and this chopper circuits and its spice simulation, so that what kind of practical curve you can get, you should get, that you'll understand. So all these are, we are discussing basically theoretical knowledge, but practically what type of curve exactly we should get, that we can see from the simulation, because here the now it is not possible to go to the lab and see what are the response we should get. So that we can discuss in some simulation class or in some extra class. Okay, so that you can arrange. That is your choice. You can arrange or you cannot. So anyway, so the thing here will take only one. Yes.
Sir. Say আমরা এই হাফ ইনভার্টারের ক্ষেত্রে এই ডি স্টেটে v0 ইকুয়ালস মাইনাস l ইনটু di dt প্লাস vd বাই 2 পেলাম। তো এই পুশ পুল ইনভার্টারের ক্ষেত্রে ডি স্টেটে তো ওটা আমাদের মাইনাস এসেছিল, সবগুলো বাকিগুলো তো সেমই এসছে, মানে সাইনের দিক থেকে সেম এসছে, অন্য দিক থেকেও সেম এসছে।
আচ্ছা এটা
ওটার
তাহলে ওই
ক্ষেত্রেও তো তাহলে
ওকে সো পুশ পুল ইনভার্টার okay so push pull inverter you just recheck that circuit and the KVL equation over there. So you got 1 week, so you should you actually you are almost 65 to 70 students in your class, so you must recheck the circuit. Is there like one already pointed out that there was some error in the expression in state B, so like that you also see take the state B equation whether you are getting correct or not.
Sir,
Yes.
স্যার এখানে স্টেট বিটা হাফ ব্রিজ ইনভার্টারের ক্ষেত্রে স্টেট বিটা নেগেটিভ কেন হলো স্যার?
স্টেট বিটা নেগেটিভ কেন হলো মানে কিটা নেগেটিভ হলো?
মানে স্টেট বি এর কার্ভটা যেটা করেছেন
হ্যাঁ
সেটা নেগেটিভ সাইডে কেন হলো?
নেগেটিভ কেন হলো? তো ভোল্টেজটা দেখো মানে কি হচ্ছে ভোল্টেজটা। জাস্ট আ মিনিট। দেখো এখানে ওই এলডিআইডিটির যেটা ওখানে বলা হয়েছে না এলডিআইডিটির মানে ইট শুড বি লার্জার দ্যান দ্য ভিডি বাই 2 না কিরকম একটা ছিল না ওখানে এক্সপ্রেশন LDIDT must be greater than VD or so. So here that is, I think that is not required. Is it required? That condition?
Sir, otherwise the current direction will not be meant because it is acting as source.
You see this equation V0 equals to LDIDT minus VD by 2. Okay, so exactly what kind of this thing you will get that depends on the voltage of LDIDT and VD by 2. Isn't it? দেখো আমি তোমাদের আগেও বলেছি যে এই যে কার্ভটা আছে সেই কার্ভটা ডিপেন্ড করছে যে এল আর আর এর ভ্যালুর উপর। হ্যাঁ সেটা ওভার ড্যাম্পড হবে না আন্ডার ড্যাম্পড হবে না কি ধরনের রেসপন্স হবে। তো এইটা তুমি বলতে চাইছো যে এই রকম কেন হলো না? Is your question is this why it is not like this?
Yes sir. Yes sir.
Okay, so that you must see over here with what type is the polarity of the voltage at that instant, output voltage, and how it depends on the LDIDT and how it depends on the LDIDT and
Sir, here the L
because here
is
L
the
is not that
inductor is
large
discharging.
but here L is
That
not
is why
large.
the current direction.
হ্যাঁ বলো।
স্যার এখানে ইন্ডাক্টরটা যেহেতু সোর্স হিসাবে মানে ডিসচার্জ করছে তাই জন্য স্যার কারেন্ট ডিরেকশনটাও আমরা সেভাবেই নিয়েছি। তো কারেন্ট ডিরেকশনটা সেইটা মেনটেন করার জন্য তো এলডিআইডিটিটা ভিডি বাই 2 এর থেকে বড় হতে হবে।
ওকে
তাহলে স্যার এলডিআইডিটিটা যদি ভিডি বাই 2 এর থেকে বড় হয় তাহলে তো স্যার ভি0টা পজিটিভ হবে।
ওকে
স্যার স্যার আপনি আগে যেটা আপনি করেছিলেন ওখানে পুটফুলে ওখানে আপনি আগে বলেই দিয়েছিলেন যে এলইএফএফ মানে এল এফেক্টিভ ডিআরডিটি ইজ গ্রেটার দ্যান ভিডি, বাট এখানে আপনি কিছু বলেন ওর জন্য স্যার নেগেটিভ এডুকেশন আসলে যদি এটা বলছেন তাহলে উপরে হচ্ছে তাই না?
That I am saying because the LDIDT here the value of L is not that large compared to the earlier case. Because in earlier
But
case,
sir, then will the current direction not be reversed?
Current direction, okay, so you are saying that why the current direction is getting reversed, because only the positive term is there, that's LDIDT. Okay, so we'll see this afterwards. Okay, you just check it whether we are writing all this expression correctly, but the practical case will get this type of response only. But again, that depends on the value of inductance. As I told, that value of inductance is the important factor in this circuit that will decide the polarity. Okay.
এটার ভ্যালু অফ ইন্ডাকটেন্স তো আগের থেকে কম, ওর জন্য নেগেটিভ যাচ্ছে।
হ্যাঁ, আগের চেয়ে কম, কিন্তু ও যেটা জিজ্ঞেস করছে যে যদি ইন্ডাকটেন্স মানে এলডিআই ডিটিটা মানে VD/2 চেয়ে বড় না হয়, তাহলে কি এই ডিরেকশন অফ কারেন্টটাকে এনশিওর করা যাবে? I think this is her question, isn't it?
Yes, sir.
She's asking that, she's saying that here also we should mention the LDIDT must be larger than the VD/2. Okay, so then only we can ensure the direction of the current. I think this is the doubt. Okay, so we'll definitely come to this, but today we don't have any time to discuss this. Definitely we'll discuss that. And if we again, I'm just saying that. Bolo.
Sir, I think this problem can be solved if we assume the VO across the complete RL load. That means if we consider the total inductor voltage inside the VO also, in that case, the in the state B, the VO will be negative. That means the upper side, because VR will be not so high as compared to LDIDT. So the V out will be LDIDT minus VR, and that will be reverse of the. That means that will be negative. And also we can assume LDI/dt greater than VD/2.
Okay, so I got his point. He's saying that in this half, whatever the inductance we assume, okay, so here, though this is like this, so this is IR and this is LDIDT, and as LDIDT, so this is the complete load part, and as here the LDIDT is more than the other part of the load, so here the effective the voltage will be in opposite direction. Are you saying this?
Yes, sir.
Understood what he is saying? Okay. Any question? Any more questions you have on this? You cannot change this. You can only change the sign. So it is minus V0, so that V0 will get, you will get the negative in the negative part, because the effective inductance there you are getting negative. But in the earlier case, the inductance which we were getting, that is not only included in the load itself. Okay, so the inductor, the major portion of the inductance was coming from the transformer inductance, which is not included in the load. So that means when we'll measure the V0, that inductor voltage will not be included in the load voltage. Am I right? Okay, so therefore this type of discrepancy is coming. Here the inductance is contained in the load itself. But in case of push-pull inverter, the major portion of the inductor was coming from the transformer, which is not included in the load. Okay, so therefore that voltage, that L effective DIDT, LF DIDT, that voltage we have to consider separately. So therefore the voltage was coming in the other half, that is the in the negative, that's similar to the previous state. Now here it is opposite to the previous state. I think that can be the explanation of this. Am I right?
Yes, sir.
কে কোশ্চেনটা করলে বুঝতে পেরেছো?
স্যার যদি আমরা গোটাটাকেই v0 ধরে নিই তাহলে তো ইকুয়েশনটাতে মানে কোনো ডিফারেন্সিয়াল পার্ট থাকবেই না।
কোনটাকে 0 ধরে নিই?
vd/2 আর vg।
না দেখো ব্যাপারটা হচ্ছে ইকুয়েশন will be similar, equation will be the same, only the thing is that what is the magnitude of this LDI/dt and where you are considering that. বুঝতে পেরেছো কোথায় আমি কনসিডার করছি এটাকে? Okay, so we'll get back to this definitely in the next class. Today we don't have any time for this. It is already 8:30. So and again I am just saying you that if you want to do some exercise in SPICE, I'm just giving the choice to you. You can accept that and we can arrange some extra class especially for the SPICE simulation. There all the practical things you will understand, what kind of polarity we should get and all. Okay, so anyway, so we have to end today's class here. Thank you very much for attending the class.